Professor Congduc Pham, that is professor at the University of Pau in the south of France. So Professor Congduc, it's really his domain is about Internet of Things, IoT, sensors, and he has a lot of works, a lot of projects on how to use IoT sensors for smart agriculture, and especially for small agricultures. So I'll give you the word.
Yes, thank you, Angelo, for the introduction. So actually, you put the three computer scientists at the end of the day. So we have the challenge is to keep you awake, especially after lunch. So I know that this is the theme of today is transdisciplinary research for a healthy planet. So I also take this opportunity to show what applied computer science research can do in this, let's say, transdisciplinary is a keyword, and then healthy planet is another keyword. Okay. So my presentation is entitled Digital Platforms and Embedded AI to Target the Smallholder Community. I wouldn't go into much detail in AI, thanks to my colleagues who introduced a little bit the AI technologies. I choose just to present what we are doing using AI and trying to put the big pictures of what computer scientists, when applied to, let's say, when applying researches, can contribute in the healthy planet problem. So there are several ways to tackle the problem of a healthy planet. And I understood that most of you here are more on the biology side, okay? So here I'm going to try to present you some contributions we computer scientists can bring, and keeping in mind how we can do transdisciplinary research. So I'm going to take the framework of two European projects, one on how to optimize irrigation in small-scale agriculture here, so in territories, and the other one how to try to increase the smallholder resilience, the smallholder community resilience. So I will try to develop these ideas and show to you how computer science can help these communities. The context of the first project is the scarcity of water. So we all know that there's a high dangers of moving lots of of moving from semi-arid to very arid areas, especially in the North Africa continent here. And we all know that the amount of water that are available for human, I mean, there's no waste of water, I believe, but the amount of water available is definitely dangerously low as time goes by. And we are moving to a period where the water resource is going to be very scarce. Sorry, you warned me about the latency of the button. Okay, so of course we want to optimize irrigation. We know that about 50% of drinkable water is used for irrigation. So we also know that digital technologies can help. We know all this. But one issue is what you can do on the scale of large farms, such as the one that you just demonstrated, with satellite data, drones, or robot, or whatever, is somehow, most of the time, very difficult to achieve when you're addressing the smallholder community. And there's a number of reasons I'm going to develop, but you can understand that the cost of the technology and the complexity of the technologies are going to limit greatly the deployment of the, let's say, what is possible. So, in our research, we have been addressing the smallholder community for more than 10 years now in various European projects. And let's say, what is a smallholder? The fact is, most of the world farms are smallholding, more than 80%, okay? So you have the charts on how they contribute depending on the size. So it is usually assumed that smallholders is below something like 10 hectares, okay? Of course, you can consider that some may have 20, but most of them have under 10. And if you look at, let's say, between 1, 2, and 5, so below 10, it already represents a big proportion of the world food security, okay? So they provide about 32% of world food supply and about only 24% of agriculture. So why am I showing this kind of figures? It's just because most of the technologies that have been deployed are actually targeting the big farms. And for the smallholders, these technologies, so robots, for instance, are too expensive, too integrated, meaning that if one part fails, you cannot repair them, okay? Highly specialized, because if you have a robot to do something, or even a sensor to do something, it actually will not be able to do something else, okay? So difficult to customize, difficult to upgrade, so there's a lot of technology barriers that make these very fancy technologies very difficult to apply in these smallholder communities. Another part than the water scarcity is definitely, and there's a lot of examples that says, indicates so, we are going probably towards more frequent crises, okay? So many kind of crises. You have the weather crisis or sanitary crisis or whatever, okay? So the last example was the COVID-19, for instance. And again, these smallholders, they don't have the money, they can't afford the technology, and they are very vulnerable to climate changes, unexpected crises, and so on. And they are de facto very economically fragile, okay? So this is a community we are targeting in our research. And we are going to try to find contributions on how to improve the technology acceptability and the technology deployment for this kind of community. So first of all, if we look at the irrigation optimization problem, we know that we could use sensors, soil moisture sensors. But the problem is when you're using low-cost soil moisture sensors, then the accuracy of the measure is not that good, okay, compared to the high-end sensors. So there's a reason why high-end sensors cost hundreds or thousands of euros, of course. So the problem here is how to exploit the data from local sensors and still being able to take decision, okay? So Angelo emphasizes on the decision-making process, and here definitely it is what we want to be able to achieve. How using local sensors being able to decide whether the soil is adequately wet or not, okay? And of course, after that, try to decide whether we need to trigger irrigation or not, okay? So there are several objectives, and it is not as simple as it seems, because I believe that for you, you understand that it is not that simple, because, well, regarding the sensor technologies, you have a lot of technologies available, depending on whether you wanted to measure volumetric water content or water potential or water tension and so on. And there are several technologies. And of course, you have to take into account that low-cost sensors are much less accurate than high-end sensors. And when you want to go from the raw value you sense to the decision of whether your soil is adequately wet or not, then you have to take into account lots of parameters: soil characteristics, soil density, soil salinity, soil texture, soil type, and so on. And then if you want to go much further, you have to take into account evapotranspiration, soil plant atmosphere continuum, and so on. So that's a lot of parameters to consider. And at the end, when you want to say, okay, now I should irrigate, how much water should I irrigate? It also depends on the irrigation type, whether it is drip, furrow, sprinkler, the plant, the crop varieties, and the relationship with all other agricultural inputs. So maybe I take the chance here to say that if we want to do all this, it's because we are doing transdisciplinary research. We need knowledge from the agronomist in order to do that. So this is how I try to illustrate the needs of transdisciplinary research, because, I mean, us as computer scientists, we won't be able to know all these relationships here between the plant, the soil, and the sensor value. So we use cutting-edge technologies, but also we want seamless integration into traditional practices. When you work with smallholders, this is a very particular community. You can go to a small farms and say, okay, you have to replace all your traditional practices by using our technologies and so on, because there's a problem of technology acceptance, and you have to adapt yourself to what they are actually doing. So you can try to put some change little by little, but if you want to radically change a practice, there's a high probability that you're going to fail, okay? So this is something that I'm going to develop afterwards in my talk, this problem of user acceptability and seamless integration of technology. Yes, so actually it is not only the cost barrier, and these smallholders, usually they don't accept technology because it seems too complex. So there's a very complex, let's say, trust relationship between acceptability of technology. So this is something that is quite difficult to handle, and I have to be honest with you, it is probably the most difficult part in any project to have technology acceptance by the final users. So this is why, I mean, in this kind of project, we also have some, let's say, non-technology part where we are going to have farmer knowledge and field-scale, field farm schools and large-scale adoption and so on and so on. So what we propose is, or what is our approach, is to provide some kind of a starter kit, completely autonomous. The goal is to have something low cost here, so less than 100 euros, where you do have a control part, so the gateway, and then you have the soil moisture devices. And depending on the sensor type, whether it is simple capacitive or whether it is a more complex or more costly tensiometer, then you are able to have something between something between 90 euros and something between 110 euros. Okay, and of course, if you want to add more sensors, you don't have to have more control part. You don't. One gateway like this could handle dozens of soil moisture sensors. So the goal here is really to have something like an intelligent irrigation in the box or plug and sense approaches, where the smallholder receives the box and then could install the sensors, install the gateway, and have direct feedback on the soil condition and being able to better take decision. Okay, so I really insist on the better terms because, again, these smallholders, they do have agricultural knowledge. They have been doing that for years. So what you can do is try to convince them that they can improve a little bit the way they irrigate, because by knowing a little bit better the exact condition of the soil, they can take better decision. Okay, but of course it is not very easy, and as I told you, the research here is to be able to work with low-cost sensors. So with our partners, we are doing a lot of calibration of the sensors in order to change the soil type and the condition in where these sensors are going to be operated. And this calibration has to take a lot of parameters because the soil textures, of course, can have some impact on the let's say, the measures of some sensors. So this is for the capacitive sensors. But sometimes the temperatures also have some impact. And the infrared radiation could have some impact also. So the calibration of local sensors are very important. So here, again, it illustrates probably more easily the transdisciplinary research that we are doing with our more pedologists, researchers on soil. I think it's a pedologist, right? with our colleagues from IRD in Paris. And thanks to them, they are conducting a lot of high-end calibration, allowing us to improve our system. So this was for the capacitive sensors, but of course we have to do the same with the water tension sensors. Even though the water tension sensors is a little bit less sensitive to, let's say, soil textures or soil salinity, still we have to verify that the low-cost system used to control the water tension sensors is suitable regarding the accuracy of the results. So this is something that we have to check also, and to provide countermeasures in order to adapt and change or maybe not change, but adapt and correct the value of the sensors itself, okay? We are working with Algeria, we are working with Egypt, we are working with Morocco, Tunisia, so North Africa, and we have to take into account that these smallholders sometimes they only read Arabic, so we have to adapt the whole system, and we have to, of course, try to find, let's say, user interfaces that convince them that the system is easy to use. So what we have to try to make is to have complex technologies made simpler. Okay, I'm not saying simple, it would be a little bit more too ambitious, but at least simpler, and I added hopefully, so we are in the continuous process of trying to optimize them. So we have feedbacks with the smallholders, and we are trying to, let's say, improving how easy our system is going to be deployed. Again, when we are using local sensors, the intelligence we have to add here is probably a little bit more than what we need with high-end sensors. So we decided to not having really, embedded intelligence on the sensor itself, but we are embedding the intelligence into the gateway itself, where we are going to add multiple knowledge streams with AI machine learning techniques, because we want to take all these parameters, or as much as possible, as we could, irrigation techniques, soil type, geographical areas, crop type, and so on. So we have to embed it into the gateway itself, and we are developing an application here that tries to take most of these parameters and try to translate them into equations and into decision-making process. And believe me, it is not that easy, and I'm going to, I'm going to develop this part later on also. And this is where we really need to talk with our colleagues, okay? Because we want to use the system to build data sets, wow, it moved very fast actually. Okay, to build data sets and to be able to make a prediction on the model. I just want to maybe highlight a little bit on the difficulties or the challenging of building data sets when we're talking about irrigation. Because as you can see, a typical irrigation or a typical soil moistures data set could be like this, okay? So you have let's say, this is the centibar water tension evolution over time, okay? But the problem is you do have irrigation cycles. And you do have the soil types, the plant types, evaporation, weather condition, and so on. So when we say we want to apply AI techniques, it is actually very challenging. It is not like you're using AI models and then at the end you just run the models and you're going to have the ready-to-use decision-making process. It is actually very difficult to try to apply machine learning techniques when you have irrigation cycle like this, because you have probably to cut your curves in several segments and try to find the right model segment by segment. So this is a kind of research that we are actually doing when we want to improve the accuracy of low-cost sensing system. I try to finish, I still have 5 minutes, right? Okay, so let me try to finish in 5 minutes by addressing another aspect of our research. So it is not on soil irrigation anymore, but it's the second project where we want to increase the smallholder resilience, okay? And the objectives here is to provide continuity of services when there are crisis situations, okay? So the approach is to allow smallholders to still maintain the access to resources, access to agricultural inputs, access to services, access to transportation, even in crisis situation, where restrictions on movements actually impact a lot on their activity. So this is where we are proposing this notion of digital platforms. Of course, the notion of digital platform is not that new, okay? We are used to have mobile apps to help us finding, let's say, you want to buy something, you want to offer something, and so on. So this is a kind of core ideas that we want to implement with the smallholders community, but it is still a research project, so we have more ambitious objectives, and the ambitious objectives is really to connect, to being able to smartly connect smallholders to new supplies, and to provide an open architectures and API. So maybe for most of you, the notion of open architectures or API sounds a little bit, difficult to understand. But the idea is not to provide another mobile app, okay? It's to provide the framework allowing all the people, third parties, local actors to use the framework to develop their own application, okay? So it is more like a platform approach. And of course, we want to integrate disruptive technologies such as Internet of Things, edge computing, lake data, and this is where some part of AI-based systems are also integrated. Maybe this picture is not that clear, so let me try to explain it a little bit in the following slides, hopefully. Okay. Is it the next slide? Okay. So we have Orange as partners, and they provide the Orange decentralized exchange place based on blockchain. So you may have heard about blockchains technologies that provide trust into a series of transactions. So here we have all the, let's say, infrastructure part to be able to handle all the transactions between the producer, the other producers, the local actors, the regulators, and all the stakeholders. And they will be able to interact each other in order to discover new resources and matches new supplies. And there are some AI modules here that I'm not going to detail, but this is what we call, this is where we are integrating AI technologies in this platform. So this is the first step where we are going to use this platform as it is, okay? And the second step is to be able to plug in our infrastructures a dedicated platform where we're going to add more features that were not specifically taken into account by the original Orange decentralized exchange place, where we want to integrate IoT data, we want to have a lightweight platform that could be deployed on small computers, And we have to be able to integrate third-party platform. You know, remember the platform approaches. So this is all the advanced features that we want to provide in this project, just to not simply have just a simple mobile app. We really want to go beyond the very simple mobile applications. I will finish with 2 slides. A lot of this transdisciplinary research that we are doing, we have to go beyond technology. Okay, technology is our core problem, but we have to go beyond. And by going beyond technologies, we have to have training program, we have smallholder piloting program, we have dissemination events, we have local innovation capacities, living lab technologies, and so on. And these are particularly important when you are doing transdisciplinary research. And this is probably the feedback that I would say about these 2 researchers. It was not easy to try to collaborate with the local actors. That's a lot of discussions, a lot of meetings, but we have to talk with all these local actors because they provide access to smallholders and they provide also the knowledge of what they actually need and whether our technologies is suitable to be deployed or not, okay? So we do have a smallholder piloting program in the Intellaris project where we're going to deploy and have feedbacks from these smallholding piloting farms to be able to improve our solutions. In the Reasoning project, we have a living lab where the mobile application and the whole digital platform will be tested on a large scale with the help of Orange. And there we mostly focus on how acceptable is the sharing principle and how acceptable is the mobile application user interface. So this part is a little bit less research-oriented. It is more like integration, but it is very crucial to the success of the whole system. Okay, so let me conclude. I would say that based on the feedback, I try to present the conclusion as it is. I presented the contribution of 2 projects, one on irrigation, the other on resilience of smallholders. Objectives are different, but the same issues are very recurrent. And what we identified is probably obvious to many of you because maybe also many of you are doing transdisciplinary research, but we found that technology readiness, technology cost, technology simplicity, and most importantly, acceptability and trust are very important. And I won't take too much time here because it's probably obvious for you, but maybe I may develop a little bit here because what I found is usually when you're doing transdisciplinary research, it takes a lot of time and usually that may lead to frustration. Why frustration? Of course, there's a lot of, rewarding also, but frustration because you always have to find a trade-off between the complexity and the accuracy of your solutions. When I talk to my colleagues who are pedologists, he's going to say, okay, you have to take this into account. If you don't take this into account, then your results are going to be not usable and so on. And I kept saying, look, I can't have this value for you, okay? So what if I just ignore it? And what's the impact on my results if I ignore it, okay? So it leads to a lot of frustration. Sometimes my colleague is frustrated, sometimes I am frustrated. But at the end, we want to try to improve things, so it's always a trade-off between what you can ignore, what you can neglect, and what is the impact that you're making in the final solutions. So that concludes my talk, and thank you for your attention.
Thank you, Professor Pham. Do you have questions for Professor Pham?
Thanks for the talk. Just a small technical question. I was curious why you chose to sell the equipment rather than maybe to rent it to the local actors. Is it important that, I mean, do you think that they would be using it really continuously, and is it important? Or would it make sense for them to use it, I don't know, like a week in a like specific period where they are interested in it, and then they could just give it back and they would rent it again whenever they need it? I mean, does it make sense for them to have it all the time?
Okay, and just to, I didn't mention it into my talks, but since it's a research project, we provide the kits as free. Okay, so we provide the kits. What I say, what I said about the technology cost is, of course, in a sustainable way, these smallholders, they will have to buy from local startups or local companies, okay? And the cost of the technologies has to remain low. But within the project, we are providing the kit for free because we do have the budget for that. And we try to increase the technology acceptability and technology readiness so that local companies could take over the technologies, try to improve it, and build a local business model. It is not our goal to run the business model and make startups to build or deploy or on a very long term. It's just to a proof of concept and initiate a little bit raising awareness.
Hey, hello, thank you for your talk. I just want to comment, here it is.
Oh,
I just want to comment because I had a similar experience. I work in a project with small farmers. We wanted to implement technology, and I remember people with 3-4 hectares, they didn't believe in our technology, so they give us like 200 square meters, and then they say, yeah, you tested. And when they see the results, they said, okay, that looks good, and then we can escalate a little bit. But that process took around 4 years to escalate to more and more farmers. I mean, it's a slow process. But then we found out exactly what was the situation, how it can escalate really big. And it was, we found in our project that the farmers have one concern, and it's about money. So if they can see that they can get more profit about that, they will implement it, that's it. So we partner with some regional banks who were giving credits and saying, for every credit that you are putting, it has an interest rate, but for every credit that we are putting using our technology, the credit rate was down. And then, I mean, it has a lot of political involvement in that. But then the people start like, okay, if I get better benefits using this technology, I will implement. And everyone wants to implement our technology. And then we realize, okay, if that is happening with the banks, what happened now with the companies that are buying the products to these farmers? And then we said, if the company wants to partner with these farmers, they should use our technology to provide to the farmers, and then they will start measuring and implement the technology. And that was working really good. However, this is a lot of partnership and a lot of things that you have to be aware of how to generate money from that, because that is the other part. It's not for free because you are implementing new technology. But when we attack in that way, it was useful. So probably it can be helpful for you if you want to escalate this in a really fast way and not take too much time, because we already did that. So hopefully it's helping to you, yeah.
Yes, okay. Thank you for the feedback. We know that we need to find incentive to be able to, for these smallholders to step into technologies. In our case, this part is a little bit less, I mean, we don't have much task on this, let's say, business model or incentive, but we rely on local actors in, let's say, in a longer terms to develop a whole local ecosystem for that. And if the price, if the cost of the technology can be much smaller while keeping the efficiency high, then we believe there's more probability that at the end, the product will be more affordable. And then, of course, there's a whole local ecosystem, technology ecosystem to develop, but this is good because this is going to increase capacity building, this is going to increase local innovation capacity and so on. So anyway, thank you for your feedback.
It's really interesting. I like really the idea, and I was wondering at one point when you were going to get into the satellite data products that are now available for soil water index, greenhouse index, and say now we can scale our technology to after the calibration period. So have you looked into that, or is the next step, or it's?
We know, of course, there's a lot of knowledge streams that you can integrate into your gateway, and of course, satellite data is very important. We do have colleagues in the consortium who are working with satellite data, but for smallholders, satellite data are not, I mean, probably you need to connect the gateway to internet and then process these kind of data. In our case, we don't need internet at all, okay? So because we embed the intelligence in it. So maybe next step, when the ecosystem will be ready, we'll be able to develop satellite data, as in Europe countries, for instance, satellite data processing is quite common, but it is probably too early in the countries that we are targeting. Yeah.
But you one simple technical question. Which is the battery lifetime of your sensors? Because usually this is a big...
yeah, of course, it is one of the questions. The autonomy of the device when running on 2 AA battery, 1 measure every hour, is more than 2 years. So it's tractable. Knowing that the smallholders, depending on the, let's say, the agricultural activity, whether it's crop or vegetable crops or trees, they do have harvesting cycles. So sometimes you have to remove the sensors so they can recharge the battery or replace the batteries. Regarding the sensor itself, it depends on the sensor technology. The capacity is about several years, 2-3 years. And the tensiometer is about in the same range. So we could say that the lifetime of the whole system could be more than 2 or 3 years. Yeah.
Okay, so
but you just need to replace the battery and the sensing part.
okay. Oh, one question more.
Thank you very much for your presentation. It was awesome. And I think it's really refreshing to see a presentation talking about technology and how to implement it in the community and make it accessible for everyone in the community. Concerning the batteries that you were talking about, did you ever, during the project, consider using like renewable source of energy, for example, the sun? Especially if we are talking in countries, I don't know, you have sun exposure like Morocco, or did you test it? Did it work? What were the constraints?
Yes, of course, when it comes to renewable energy, we automatically think about small solar panels. And we actually do have a version with the small solar panels. It adds a little bit more complexity in the electronic design. No big deal, of course, but it adds cost. This cost could be neglectable, okay, with regard to the final advantages. But one main disadvantage is why we didn't want to deploy this at the first step is the solar panel is quite, the deployment is more complex, and the device itself is more fragile. So when you're talking with smallholders who it is the first time they actually step into technology, you know, they take the device and sometimes they just throw it, or they install it, or they store it, you know, very brutally. They don't, let's say, take care of it, I would say. So we didn't want it to this kind of problem. So we say, okay, in the first step of the deployment for the piloting program, we are going to use AA batteries that last for 2 years. And then afterwards, we do have the solution ready with the solar panels. And if some startups want to improve the whole system, they are going to do so. But it's a long-term effort. So this is why we didn't want actually to go into that kind of things, which typically makes sense, yes.
Thank you, Professor Pham. If you have any more questions, you have the coffee break after. So thank you very much.